In this section, we're going to quickly go over the basic differentiation rules that would help us speed up finding the derivative. I'm going to go over this really fast because we're going to practice this in class. Okay, rule number 1, derivative of a constant function. So again, remember that derivative means slope. So the question is, what is the slope of a constant function? Well, if constant function means a flat line, right? So the derivative would just be 0. So the derivative of actually any number is always 0 because it's a flat line and its slope is 0. All right, second rule, power rule. So the power rule says if n is a positive integer, then d dx of x to the n is n times x to the n minus 1. So remember, d dx means derivative of power. So variable to a power. That power is a positive integer. Then what you can do is take that power, put it in the front, put it in the front of the variable, and then take the power and minus 1. So for example, if the function were x to the 6th, then the derivative would be 6x to the 5th. So take the power, put in the front as a coefficient, and then subtract 1 power from the original power. Same thing here. I guess I probably should say not a positive integer. It's just n is just any number, and it could be a fraction or it could be a integer. Doesn't really matter. It could be positive, negative. Doesn't matter. We're gonna do it the same way. So if the function were 5 over x to the 3rd, that's a little bit tricky. So what we want to do is recall that we can turn this into x to the negative 3. So then the power rule says we are going to take the power and put it in the front as a coefficient, the original function, and then x to the power minus 1. That's negative 4. Please be careful with negative 4, not negative 2. So this becomes negative 15, x to the negative 4. That's the second rule, power rule. Rule number 3, constant multiple rule. So it's pretty much what I just showed you in rule number 2. So if u is a differentiable function of x and c is a constant, then dcu is c du dx. Meaning, if you're trying to take the derivative of this whole function and c being a coefficient, u is a function, you can actually just put c in the front, kind of like this, and then take the derivative of the function. So for example, if this function were 3x to the 4th and you were trying to find this whole thing at once, then you can put the 3 in the front and then do the power rule. So 4 times x to the power minus 1, and then this becomes 12x to the 3rd. So pretty easy stuff. Number 4, sum and difference rule. Very easy. It's just saying that if you have, instead of one function, you have multiple functions added or subtracted together, like this, u plus or minus v, then you just take the derivative of each one separately. So for example, if the function were 5x plus x cubed, then the derivative of the function would be the derivative of 5x, which is 5. So remember, this is really x to the 1st, right? So then if you were to take the derivative of that, the power rule says put the 1 in the front, which is kind of irrelevant, and then power minus 1, power minus 1. So that becomes x to the 0, right? X to the 0 is just 1, so that part is just 5. And then if we were to take the derivative of that, we would get 3x squared. So then the overall derivative is 5 plus 3x squared. Okay? Derivative of sine and cosine. This one you just have to memorize. The derivative of sine is cosine. The derivative of cosine is actually minus sine. So please be careful. There is a minus on this one. A lot of people forget which one has the minus. I did too when I was in high school. So you kind of just have to memorize it and kind of force yourself to review it once in a while. Okay, so let's try. Find the derivative of the following function. So this is the sum and difference rule. So we take the derivative of each one separately. So the derivative of x, So the highest exponent is 1, so then that's going to be 1. X to the 1 minus 1, so x to the 0, which is just a constant. So the derivative of x is just 1. In fact, the derivative of any linear function, so for example, 3x, the derivative of 3x is just 3. And if you kind of think about it, it makes sense, because if you have 3x, which is just a linear line with a slope of 3 and a y-intercept of 0, so then if you ask yourself, what is the slope of that line? Well, it is 3. So any linear function, that means degree of 1, the slope or the derivative is just the slope of the line. Okay, derivative of cosine is minus sine. All right, number 2. The derivative of this one, okay, again, derivative of cosine is minus sine. This is a, what is it called? Like a constant multiple. So the pi over 3 stays out on the outside, and then we take the derivative of the function. The function derivative is cosine. Like that. All right, next one, derivative of the exponential. Well, this one's pretty easy, actually. It's the derivative of e to the x is just e to the x. So e to the anything, it's just e to the anything. And we're going to talk about this part later. For now, if it's just an x, okay, so keep that in mind. If it's just an x right now, we just rewrite e to the x. If it's not an x, if it's e to the 2x, then we need a rule that you're going to learn later on to help you solve that. For now, just remember e to the x is e to the x. All right, so putting all the rules that we have learned together. The derivative of f of x for number 1. Derivative of sine is cosine. Derivative of e to the x is e to the x. So easy. Derivative of v of t. Derivative of tan, remember constant is a flat line, the slope is 0. So I'm just not going to write it. The derivative of negative 5 e to the x, so constant multiple, so constant stays in the front. E to the x is e to the x. All right, now that we have went over the derivative rules really quickly, let's use the rules to help us solve some problems faster than if we were to use the definition of derivative. So for example, let's look at this one. A billiard ball is dropped from a height of 100 feet. The ball's height s at time t in seconds is the position function. All right, so they tell us that where the ball is depends on t, and then it's this equation. The first question is, what is the average velocity over the interval 1 to 2? All right, so here's the trick. So if you're taking physics, it makes a lot of sense. If you didn't take physics, you're going to have to learn some physics in this class. So the trick is knowing the relationship between position, velocity, and acceleration. And then we'll kind of talk about that pretty much the entire class. So usually when we talk about position, we would say s of t. So s usually means position, or sometimes they say x as well. When we take the derivative with respect to the variable being t, we get velocity. And then if we take the derivative again, we get acceleration. So what we're doing is we're just differentiating with respect to time. So write it like this. This is derivative. So this is very important. This is probably guaranteed on the test. So position, position, velocity, acceleration. And then we'll talk about how is position different from distance later. They're actually similar but a little bit different. And how is velocity different from speed later? unless it will show up in this problem, but I don't think it will. So anyways, just remember, to get from position to velocity, you take derivative. To get from velocity to acceleration, you take derivative. All right, so let's look at this question again. They tell you the position is this equation. The question is, what is average velocity? Okay, so then the first thing you ask yourself is, how is velocity related to position? It's related by derivative, right? So the question is, how do I get the derivative from this? Well, we can get derivative using many different ways, right? We have the definition of derivative, or we can use the tricks that we just learned. But the key here is, what kind of derivative, or what kind of rate are we looking for? Average rate. So when it says average, you need to remember that at the beginning of the chapter we learned two things. We learned one thing called IROC and the other called AROC. IROC means the instantaneous rate of change. What is the rate of change at that instant, at that 1 point? Remember, 1 point. The second one is AROC, which is the average rate of change. Average means it's a secant line, so it's between 2 points. It's between 2 points. So then you ask yourself, what is this question asking for? Are they asking for IROC or AROC? Well, the average kind of gave it away, right? So it's asking for the average between 2 points. What 2 points? 1 and 2. So then the question is, what is the velocity over 1 and 2? All right, so the velocity between 1 and 2 is really just the AROC function. The AROC function is going to be the S, so the position of the second point, let's call T2, minus the position of the first point over the difference in time. So remember, this is really change of y over change in x, right? Because slope is just the derivative. And then we know that velocity is the derivative of position. So if you were to plug it in, you would say s of 2 minus s of 1 over 2 minus 1. All right, s of 2, just plug it into the function, minus 1 all over 2 minus 1. All right, negative 16 times 4, that is negative 64, plus 100 minus 16, so plus 16, minus 100 over 1. Okay, that's irrelevant. Over 1. Okay, so then we get that cancels out. So negative 64 plus 16 is negative 48. So the average velocity over this interval is negative 48. Now let's try to put in the unit. What's the unit of velocity? Velocity is always distance over time. So we know that distance unit is in feet. The time unit is in seconds, so this is feet over seconds. All right, so let's go ahead and have you try the next one. This one you probably have to use the calculator because the interval is not integer. So what is the average velocity over 1 to 1.1? All right, pause the video and give this a try. All right, the answer is negative 33.6 feet per second. Then part C says, then what is the instantaneous velocity? What is the instantaneous velocity? So this is kind of a dead giveaway, right? Instantaneous. So what are they asking for? They're asking for IROC. So how do you find IROC? You just find the derivative. So we know that the derivative of the function, the derivative of the position function is velocity. So then we have to find the derivative of the position function. And then this is the sum and difference rule. So we're going to take the derivative of each one at a time. That is negative 16. That's a coefficient times the derivative of that function. And the derivative of 100 is 0 because that's a constant. So this is negative 32t. So this is the velocity function. Now we want the velocity at 1. So we're going to plug that in. So negative 32. All right. And then the question is, what is the unit? Feet per second. All right. Let's try another one. At time t, a diver jumps from a platform diving board that is 32 feet above water. Because the initial velocity of the diver is 16 feet per second, the position of the diver is this one. All right, so they give you a position equation. When does the diver hit the water? When does the diver hit the water? Okay, so if you're not sure what you're really looking at, you have this guy who is going to dive down, and they tell you that this diving board is 32 feet above water, and then he's going to jump. So the question is, when will he hit the water? When will he hit the water? So let's just say that I make a coordinate system like this, and then I call this 0. I'm sorry. This is basically like if I think of water as the x-axis. So he is 32 feet above water right now. When is he going to hit the water? Well, that's when x is 0, right? So what we can do is just plug in 0 for the position. That's where he's going to hit the water. And then try to solve for t. All right, this is pretty easy because you could just factor this and solve it. So I'm going to divide everything by negative 16. So then I don't have a negative leading coefficient. So t squared minus t minus 2. And then I'm going to just factor this. T minus 2, t plus 1. So then t is 2 or minus 1. Now you ask yourself which one makes sense. Of course, 2. Because when it says at time t, he starts jumping. So you're not saying he was at the ground at negative 1 second. And anyways, it just doesn't really make any sense. You need to go forward, not backwards. So t equals 2. 2 seconds is the answer. Next one. What is the diver's velocity at impact? At impact. At impact means when he hits the water, how fast was he going? Well, when does he hit the water? 2 seconds later. How fast was he at 2 seconds? Well, that depends on this function, right? So how fast was he going? That is a velocity question. And then remember, velocity is the derivative of position. So go ahead and figure out how fast was he going when he hit the water. All right, the first thing we need to do is take the derivative. And then we plug in 2. So it says he was going negative 48 feet per second when he hit the water. All right, 2 more examples. This is a typical one where you're given a table. So the question says, what is the average rate of change of the function h? Okay, so this is h. So then it's asking how fast is this function changing in terms of s when s is increasing from negative 1 to 4.5. Again, the question you ask yourself is average rate of change. Average rate of change is asking for what? AROC. In fact, it's just the acronym of that. So what is the AROC of h of s from negative 1 to 4.5? So very easy. It's just going to be h of 4.5 minus h of negative 1 over 4.5 minus 1. We're saying what is the average rate of change? So what is the secant slope of h from -1 to 4.5? So if you were to draw this function h, I don't know how it looks like, it's saying what is the secant slope? So between -1 to 4.5, and then, let's say there are 2 points on here. What is the secant slope? It is really that, and then, we just basically do, change of y over change in x. Except this time you have a table, so then you just need to pick the points from the table. So h of 4.5 is 38.8. H of -1 is 25.6 over 3.5. And then calculate that. The answer is 3.771. All right, so one thing about the AP test is you must have 3 decimal places. Please don't round to tenths only. That is 1 decimal place, because it would just be wrong. All right, last kind of question. Does the following curve have any horizontal tangent? If so, where? So the question you ask yourself is, what does horizontal tangent mean? What does horizontal tangent mean? So horizontal, we know what that means, flat horizontal line. Tangent, we know what that means. That means a line that only goes through 1 point. So it's really asking you, on this curve, so let's say this curve looks like this. On this curve, is there any point where there is a tangent line and that tangent line is horizontal? So like this, the tangent line is horizontal. So how do you figure that out? Well, if you think about it, a horizontal tangent line would have a slope of what? A horizontal tangent line has a slope of what? Well, any horizontal line always has a slope of 0. So then we're saying, we don't know where, but as long as the slope is 0, it's probably going to be a horizontal tangent line. So then the next question you ask yourself is, how do you figure out where you have a horizontal tangent? Or how do you figure out where you have a slope of 0? Well, slope, remember, means derivative. So the question is really asking you, where is the derivative of 0? All right, so we're going to take the derivative of the function. So that is 4x cubed minus 4x. And then you're going to make it equal to 0, because they're asking you, when is slope 0? I'm going to try to factor. If factoring doesn't work, then I'm going to try to use the calculator, but it looks like it's working. So x is equal to 0 plus minus 1. So at 0 plus minus 1, the horizontal tangent would be 0. Okay, so let's go ahead and see how decimals look like. So if you were to look at decimals, you can see that this graph looks like this. And so we said there are horizontal tangents at 0 plus minus 1, which is true. 0 and then -1 plus 1. They all have, if you were to draw a horizontal line through those points, you would draw a flat horizontal line. So that's correct. Just one thing to know, please put in the original function if you were really going to check. Don't put in this one. The derivative one is not going to look the same as the original function.